All right, so today we're gonna start from taking a look at example 53 here. This is the one that we stopped last time. So the last time we said that if we have the function sine and cosine, you have the function sine here. And you also have the function cosine here. So you actually found that the area that you want to compute, it's here. So you can set up the area as I told you that here you can have 0 to pi over 4 sine x minus x. This is because you have the first piece here from 0 to pi over 2, the one that I put the laser on now. You can see that if you place yourself in there, so the roof gonna be the function sine, but on the ground gonna be the function y equal to 0. This is why you have sine x minus 0 here from 0 to pi over 4. And then another piece, if you have here, you put yourself there, so you're gonna see that the roof gonna be cosine and the ground gonna be y equal to 0. And then that means integrate from pi over 4 to pi over 2, which is here to here. So you're gonna be stand here, and then on the top you're gonna have cosine and the bottom is 0. And once you set up the area, the remaining part, it's going to be just the basic integration as you learned before. So the new part that you're gonna learn for this chapter is going to be the one that you set up the area. Later on, you're gonna set up the volume as well, okay? So the thing that you learned from last time is that if you have the region R, you actually can compute the area by integrate from A to B, and then you use the top function minus the bottom function. Okay. At this point, you may have a question that, is it possible to do the slice? But this time you're gonna do the horizontal one. Because if you do the horizontal one, you may not need to split the region into two pieces, right? Because you can have this red one to the blue one all the time. The answer is you can. You actually can do it if you want to. You don't have to do the x. So the theory says that if you want to do integrate dy, we're gonna say that you can also find the area of the region between two curves with respect to y. In this case, what you're gonna do, you're gonna do dy. Y start from C to D. So how does it work? You're gonna do the right hand curve first, and then you minus the left hand curve. So what you see in the picture here, let's say you have the right hand curve x equal to fy. You have x equal to gy. This is the left hand curve. And if you want to integrate from C to D, which means you have this area. So you actually can do it. It's going to be integrate from C to D. C to D is going to be the range that you integrate. And then you start from the right hand curve minus the left hand curve. Always do the right hand minus the left hand, always. And then if you set up this way, you use dy, it's gonna be the case that you can have the region or the area of a region as well. Okay, let's try to do example here. So find the area of the region bounded by the graph y equal to x minus 2, and also the curve x equal to y squared. So for this one, you actually need to draw the picture first, of course. So we're gonna draw the picture here, y. We're gonna draw the picture here, x. And then now you're gonna trying to do the, let's say parabola first. So you have x equal to y squared. This is the parabola here, right? X equal to y squared. It's just parabola one. And then you also have y equal to x minus 2. So in order to plot that y equal to x minus 2, if you let x equal to 0, you're going to have y equal to 2. And if you let y equal to 0, you're going to have x equal to 2. Oh, sorry, let x equal to 0, y going to be minus 2. Right? If you let x equal to 0, y going to be minus 2. And if you let y equal to 0, x going to be 2. That means the graph going to pass the point to 0. And then going to pass the point 0, negative 2. All right. And once you have the intercept, you can draw the line. So this is actually the line y equal to x minus 2. So once you have these two curves, you can shade the region you want. So this is the one that you want is here. Because this is the region bounded by the curve y equal to x minus 2 and x equal to y squared. So it's actually here. And now you want to find the area of R. So the area of the region R is going to be what? So now you can see that you have two ways to do it. You have two choices. You can do dx or dy, depend on the question. But if you do dx, you're going to do this. This, you slice the horizontal, the vertical one. You're going to use the vertical one if you use dx. But if you use dy, you're going to use the horizontal one. This is dy. So we're going to learn how to use dy in this question. So we're going to just say that if I want to integrate this thing, I want to use something with respect to y. What would you do? Integrate with respect to y, we're going to say that here, this is the parabola, and this is the line here. So the parabola here, you're going to have the equation x equal to y square. Remember, this is x equal to y square. This is actually y equal to x minus 2, but you can simplify it. If you simplify it, it's going to be x equal to y plus 2. Remember that we have to put the y function in there, not the x function. Remember from the theory that you actually need x equal to fy and x equal to gy. You actually need to simplify to get x equal to something, x equal to something. Once you have the function of y, you can plug in the function of y in there, and in there, right, plug in function of y in there and there. So you're gonna have the area. So this one, we're gonna plug in the right-hand curve to be this one, the line. So we're gonna plug in y plus 2 first. This is my right-hand curve. So my left-hand curve, it's gonna be y squared. So this one, to make sure that everyone can follow, so we're gonna make sure that we know this thing. This is going to be my left curve. This is going to be my right one. Because every time when I do this, on the right-hand side, I have the line. On the left-hand side, I have the parabola. And then what is going to be my so I put the parentheses first. So what is going to be my upper bound and lower bound of the integration here? So it's gonna be the range that you do the horizontal slice, this one to this one. So that means you have to find the intersection here. What is going to be the intersection here? So you need the intersection. So this one, you can just, set up the equation and then you solve for y. So x equal to y squared and x equal to y plus 2. So you can have y squared equal to y plus 2. And that means y squared minus y minus 2 equal to 0. That means this thing y minus 2 and y plus 1 equal to 0, right? Because you do the factoring. And then this time you're gonna have y equal to -1 and 2. So this means this point is y equal to -1. This point is y equal to 2. So on this interval -1 to 2, this is the one that you actually do the slice here. So that means here gonna be -1 to 2. Does it make sense? So you have to make sure that you know everything about the picture first, because this is what I told you, that like the picture is the most important part for this chapter, because as long as you can draw the picture correctly, everything gonna be fine. Okay, and then now you integrate it. So I mean, the remaining part is gonna be just the basic calculus. So integrate y, you get y squared over 2, and then integrate 2, you get 2y, and then follow that minus y squared, you integrate, you get y cubed over 3, and then now you evaluate at y equal to 2, and evaluate at y equal to -1, and then you compute the value. So I'm gonna do it pretty quick here. 4, not 4, 2 plus 4 minus 8 over 3. This is what I plug in y equal to 2, 2, and 2. So take your time. This is going to be the number. And then you plug in 1. So it's going to be 1/2 minus 2. And then plus 1/3. And then once you calculate this fraction and numbers, so 9 over 2 square units. This is going to be the answer for this question. So the answer is 9 over 2 square units. So this is the example that you can see that this one is easier if you do dy. Because what if you do the x? If you do the x, you have to split the region into 2 pieces. And then you do the vertical line here, and it's going to be terrible because you have to start from this first interval and then the second interval. It's going to be terrible because you have to split into 2 integrals. Does it make sense? So you have to be super smart and be critical on what you pick, the x or the y. Okay. All right, we're gonna have more examples for you to practice about slicing the integration dx and dy. Okay, let's do the next one, 155. So today we have the recording, so I'm gonna post the link on my course view later. So you, in case that you wanna look at the lecture again, the video lecture again, you can. Okay, so next one, 155. This time I want you to express the area of the following regions in terms of one or more integral with respect to x, one or more integral with respect to y. This means that you have to do both the x and the y, but this time you do not need to evaluate the integrals. Okay, so let's see. This one is the keyword. You don't have to calculate it. That means when you set it up here, the answer is going to be here. So you don't have to calculate this thing. I just want to see if you can set up the area. All right, so first of all, draw the picture here. So you have x cubed, x plus 6, and the x-axis. All right, so we're gonna start from x cubed. So this is x cubed. If you never learned x cubed before in your life, memorize it. This is the graph of x cubed. So whoop, like the curve like this, called x cubed. All right, and then x plus 6. This is the one that it is aligned. So you can find the intercept first. When x equal to 0, y equal to 6. This means this graph gonna pass 0, 6. And then also if you have y equal to 0, x equal to -6, right? This means the graph gonna pass also -6, 0. So the graph gonna pass these 2 points, This is amazing. So you draw the graph, but I mean, my scale is not that good. So I'm gonna change 0.6 here. So when you draw the graph, you don't have to be that perfect. Just make sure that you label everything. So the scale doesn't have to be that perfect. So I understand because we don't have the graph paper on the exam or something like that. You just sketch it. And then the last one that you have is the x-axis, which is this one, the purple one, but it is the axis, so you don't see the difference. But the x-axis is also y equal to 0. This one is y equal to x plus 6. So now you can see that the region that you want is this one. All right, this one. All right, now we're gonna trying to set up the area here. First one, we're gonna use the x, and another one, we're gonna use the y. Okay, let's see what happened here. So before we find the area, the x or the y here, we gonna just find the intersection first, because you can see that this point is actually -6 and 0. You already know it. This one is actually 0, 0 for sure. This is the origin. But this one, another one that I just put the dot on now, the cutting point between x cubed and x plus 6 here, this is 2 and 8. How do I know that it's going to be 2 and 8? Because I actually solve the equation x cubed equal to x plus 6. But I mean, if you are very fast, you can see that x equal to 2 going to make it work. But if not, you can solve for that equation. In order to solve this equation, it's going to be super terrible because you're going to need to factoring this one. You can factor x minus 2 from the x cubed one. And then that means the one solution is going to be x equal to 2. And that means 2 here going to be the answer here. But on the exam, I will not ask you to be the I will not ask you to do the cubic factor. So if you have to do the cubic factor, the factoring gonna be given. So don't be worried about the factoring the x cube, because on the exam, you're gonna see only x squared. So you don't see x cube on the exam for sure. So this one, we actually do it together in class. So I already factor it for you. You have this, but I mean, we're not going to spend time finding this term because it's useless, because we already know that 2 is one solution and this match with 2 and 8 here. So we already have the region here. Sure. All right, so the easier one gonna be the y, because if you slide this way, you can see that every time you start from green to red, green to red all the time, right? So that means in this case, you're gonna do red minus green, right? And then once you do red minus the red curve here, minus the green curve, done. Because every time you draw the slice here, the horizontal line, the red curve on the right hand side, the green curve on the left hand side, and then you're done. So we're gonna see what is my red curve and green curve here. So the red curve is y equal to x cubed, but you have to switch to x equal to cube root of y, because you actually need x in terms of y. You cannot put x cubed here because this is dy. It need to be the same variable. If you want to do dy, this function that you put in there should be y as well. This is why I say that the red curve you have to simplify to x equal to cube root of y. Same thing here. You have to simplify it to x equal to 6 minus y. If I did it wrong, you can type it in the chat. Y minus 6. Okay, sorry. Okay, this is y minus 6. So I'm gonna put the y minus 6 in there. All right. Make sense? So this is the one that on the right hand side. Yes. One on the left hand side. Yes. And then y gonna start from 0 to 8. Okay, so it's 0 to 8. All right, this is area with respect to y. But if you want to do with respect to x, it's going to be a little bit terrible because you can see that you're going to have this piece first that when you draw the vertical line, it's here. This bit, when you draw the vertical line, it's here. Different because this one you start from the the x-axis and then you hit the x plus 6 line y equal to x plus 6 all the time. But this one you start from parabola and then you hit the line. So split the integral. So split into two pieces. So the first one from -6 to 0 and the next one from 0 to 2. I mean, the scale is not good because -6 should be super far, but this is 6 unit. This is 2 unit. My scale is not that perfect. It's not to scale, but I mean, just know that this is just a sketch. And then from -6 to 0 here, you're gonna use the top function. Remember this one, you need to use top minus bottom one. But the top one is the green line here, which is x plus 6. So y equal to x plus 6 gonna be on the top one. And then the bottom one gonna be 0. So you're gonna integrate x plus 6 minus 0 here on the first piece. The second one, you're gonna do the top one gonna be x plus 6 as well, but the bottom one gonna be x cubed, right? Because this is a top minus bottom, this is a top minus bottom, top minus bottom, top minus bottom. So if you understand the mechanism of this one, this chapter is gonna be super easy for you because basically what you're gonna do is you're gonna draw the picture and then you need to know which one is on the top, which one is on the bottom, and then you're trying to set up the integral. So the question on the exam gonna state that do not need to evaluate the integrals. So make sure that once you have this thing, do not need to simplify anything. Just leave it there. You're gonna get full credit. That's it. So this is the thing that I want you to do to practice because the exam you're gonna have similar question. Okay. All right. So let's do one more, everyone. So we're gonna do one more here. So this one you do both dx and dy as well. So let's see. So you have y equal to e to the x, y equal to e to the minus x, and x equal to log 3. All right, so let's draw the graph. Ship. Y equal to e to the x. Okay. The first one. The second one is y equal to e to the minus x. Ship. All right, this is y equal to e to the minus x. For those of you who are super, for those of you who already forgot how to draw the picture here, so this is actually y equal to 1 over e to the x, right? If you do y to the e to the minus x here, it is the same thing with y to the e to the negative 1 to the x, or it's 1 over e to the x. So the curve gonna be the same with exponential function, but you just, because your base here is e to the negative 1, so it's gonna be the decreasing function. And then you have this function. And then x equal to log 3, this one. All right, so you have x equal to log 3, and then this point gonna be 0, 0 for sure. This point gonna be x equal to log 3, then y equal to 3. This is x equal to log 3, y gonna be 1/3. Okay, so this one easy on the picture and easy on the intersection. And then you see that the thing that you have for the area is on this one. All right, so you actually have the region R already. So now what is going to be your area? So the area, you do both the x and dy. So let's first do the x first. So if you do the dx one, So you cut. This is the easy one because every time when you draw the vertical line, you start from the bottom curve and then you hit the top curve here. So the top curve gonna be e to the x, the bottom curve gonna be e to the minus x. This is super easy one because you actually already have the, okay, I'm trying to do the same color. The bottom curve, the green one. The top curve, it's the purple one here. You can see the purple one is the top curve. The bottom curve gonna be the green one. All right, so this is why you do the top minus the bottom one, and then that's it. And then the x value gonna be 0 to log 3, right? Because you start from x equal to 0, and then you keep going to x equal to log 3. All right, so the hard part, let's see, area. This is integrate with respect to y. So if you do integrate with respect to y, so you can see green one to the black one, green one to the black one. This is the first piece, green to black. And then the next one, purple to black one. So this means you have to start from integrate. The first one gonna be the black one first, and then minus the green one. And then you use dy. And then the next one, you use the black one as well. Because black one is on the right hand side. And then you minus the purple one, dy. So you can see that black minus green, black minus green. So the black one minus the green one gonna start from, oh, sorry, this is not 0, 0. No? This is 0, 1. This is 0, 1. Okay, 0, 1. Okay, so this is actually 1/3 to 1. And then 1 to 3, right? 0, 1/3 to 1 first, and 1 to 3. So 1/3 go to 1, and then 1 go to 3. So from 1/3 to 1, 1/3 to 1 here, which is this piece. So let's see that you have black minus green, but the black one is x equal to log 3, which is good. You can put log 3 in there. The green one here, okay, let's simplify. So it's going to be x equal to minus log y. And the purple one, if you simplify, x equal to log y. Okay. So which means you can now black one minus the green one, which is, all right, so that is the first piece. The second one, black one minus the purple one. So the black one minus the purple one. All right, and this is the answer for this question. So you leave it there on the exam, and then I'll check. That's it. Similar to the exam, 4 points on the exam for this question, that I ask you to draw the picture and then set up the area. Okay. Any questions, student? You can leave the question in the chat if you want to. If you want to ask question, you leave in the chat. So I am going to read the chat. But if not, let's learn a little bit more. This is 11:04 now. I think we can go further, no? This is the problem about the area. So summary. So step to find the area. Sketch the bounded region first. If it is not given, you sketch the region. And then you find the intersection points if need. And then now you decide if you want to integrate with respect to x or y. Depends which one is less work. You usually use this one. You should ask yourself that it's lined up nicely into vertical strips or the horizontal strip works better. So it depends on you, because like this one, x better, dx better. This one, dy is better, right? It depends on the question that you have to But I mean, the most important step is the sketch the region one. If you can sketch it, you're gonna be good. And then the last step gonna be you calculate the integral, which I mean, usually I'm not going to put a lot of focus on the last step because most of the time the question gonna say do not evaluate the integrals. Okay. All right. So let's move to the new content today. So we're gonna learn maybe 2 more examples, and then once we are done, we're gonna tell you a little bit about the exam that you're gonna face, the final one on the November 29, which is coming in 20 days. All right, so volume by slicing. All right, so last time we learned how to calculate the area, but this time it's gonna be the volume. Imagine that you have the volume like this, the solid, not the volume. You have the solid like this. So this solid is so special because when you cut the solid by the plane here, so what you have is you're gonna have the cross section, and that cross section, you actually have the same shape for the entire solid. This one is going to be a good case because in order to find the volume of the solid, you can just find the area on one slice first, and then now you integrate from A to B. That's gonna be the volume, right? Because if you cannot follow this one, let's try. You're gonna have start from this one, for example, and then if you slice it into the small pieces, you can actually compute the volume for each piece, and then you add them up. You're gonna get the volume here, right? But in order to get the the correct number of the volume here, you have to slice infinitely times. Because if you slice like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is you slice only 10 pieces. You're gonna have a little bit of error compared to the volume up here. If you slice 20 pieces, it's gonna be a little bit better because the approximation gonna be better. But if you slice more, maybe 30 pieces, so it's gonna be close to the picture, the correct volume now. If you slice infinitely many times, that means you take the limit into infinity of the Riemann sum, you're gonna have integral. So this is the case that when you do the volume by slicing, when you know the cross section here as the A here, so you're gonna integrate from A to X. For those of you who cannot follow, think about the loaf of bread. When you buy the loaf of bread from the supermarket, if you want to find the volume of the bread, what would you do? You can slice it to small pieces, right? And then if you add all small pieces together, you're gonna get a big one, a loaf of bread. This is similar to this one. But in order to sum each piece, instead of summing each one, we're gonna cut infinitely times. Slice it, chop it up infinitely many times. That means you're gonna do the integration because the limit of the summation is the integration. So the idea of the integration is that when you see the summation and then you want a summation infinitely many times, n go to infinity, limit of sum gonna be replaced by integration. This is the meaning of the integration in calculus. So let's try. So the question gonna give you AX, which is the area of the cross section. They're gonna give you that, hey, when we cut the cross section gonna be this shape. And then what you have to do is you find the AX first, and then you just put the upper bound and lower bound. This is where you integrate from here to here. This is A to B. Okay, so let's see the real problem here. So you can see, all right, so one more before you start the problem. So you need to sketch the base. Does not make sense here, but sketch the cross section, and then you find the area for the cross section, and then you put it in the integral. So let's do it. All right, so this is first example here. I'm gonna tell you that it's a little bit hard for those of you who are not good at geometry because it requires a lot of imagination in 2 and 3 dimensions. So let's trying to part this thing first, part the first 2 example first, because it may look super complicated in the as a picture at first, but I'm not going to ask you to draw the picture of the solid. So this is a picture for you to understand the mechanism. So the volume of a parabolic cube. So we're gonna let R be the region of the first quadrant bounded by the coordinate axis and the curve 1 minus x squared. Basically, you're gonna know yourself that you actually have this curve y equal to 1 minus x squared. And then I am only interested in this part on the first quadrant bounded by the curve and the x and y axis. So once you have this one, the region here, so I'm gonna use this one as my base. So it means in 3 dimensions, C is here, Y is here, X is here. So in 3 dimensions, I put that yellow one down here. So from there in 2 dimensions, I just put it there in 3 dimensions here. It's just like, you know, you put it, this is just like the projection of the 3 dimension into 2 dimension. I mean, if you put the camera on the top here and then you just take a look with no height at all, so you're gonna see the same picture as this one. And then the question said that you're gonna have a solid that has a base R, and the cross section to the solid perpendicular to the base parallel to the y-axis are squares. That means every time when you cut this thing, you're gonna get square. Every time you cut, you get square. So the good picture is here. Every time you cut, you get square. Every time you cut, you get square. Every time you cut, you get square. And then once you sum all the square together, you're gonna get the solid here. What we compute here, we wanna compute the volume of the solid that you cut it and then you get square as a cross section. Does it make sense? But I do not want you to like be worried about the picture here because I'm not going to ask you to draw the picture. So what you need is you need to set up the integral and compute it. So this one is gonna be ax, because ax is the square one. So the formula for the square is sine square, right? Because for the rectangular, the square one, so x here, the area is going to be the sine square. So I mean, if this is my sine and this is my sine, so sine square gonna be the formula of the area here. And then that's mean the sine here. How do I know that the sine is gonna be what value? So I'm gonna take a look at this one, which is similar to this one, right? It's gonna be the top curve minus the bottom curve. Can you follow that? So this is actually I want to know the size of the square here. And in order to get that length, so I'm gonna go back to my base picture, and then it's similar to this line, right? So this means that you have to do the top curve minus the bottom curve. This is actually 1 minus x squared. Actually, the side one. This is actually 1 minus x squared minus 0, which is 1 minus x squared, because you actually do the top minus bottom. The top minus bottom. This is the top minus bottom, and that is here. And then you have the side, you put the square over there, and then you get expand, you get this one, and then you integrate to get this number. 0 to 1, how do you get 0 to 1? This is where you put the vertical line. Similar to the thing that you learned for the region. This is 0 to 1. All right, so this is the mechanism of the volume by slicing. A little bit hard, but we're gonna put everything together and do the example, the blank one. We're gonna do the blank one together. All right, so let's do this one together. All right. A solid has a base that is a unit circle x squared plus y squared equal to 1. The cross section to the solid perpendicular to the base and parallel to the y-axis are equilateral triangle. So can you calculate the volume of the solid? So this time the base gonna be circle. And every time when you cut to the circle here, you get the triangle. Every time you cut, you get a triangle. Every time you cut, you get a triangle. And once you get the triangle for the entire range here, you're gonna get the solid like this. Make sense? We wanna find the volume of this solid. All right, so first of all, let's draw a base first, because this is going to be the good one to investigate the volume. So you need to start from the base. So they said that the base is this one, the unit circle. All right, so how many of you cannot draw the circle here? It's ChPE and ChPE, right? This is x squared plus y squared equal to 1. Just the unit circle, simple one. So this is the x equal to 0, y equal to 1. This is 1, 0. This is negative 1, 0. And then 0, negative 1. This is just the unit circle, the very simple circle that you have seen it before in, whatever, like if you learn Matayom in Thai, it's gonna be like Matayom 3 to Matayom 6. If you learn in international school, I think you see the formula of the circle in grade 10 or something like that. But whatever, so this is actually the formula of the circle. And then once you have this thing, this is your base, everyone. This is your base circle here. And once you have the circle here, imagine that you're gonna put the circle down there, like in solid, in 3 dimensions. You're gonna put the solid down there. You're gonna put the circle down there. And now this time, every time when you cut to the circle here, you're gonna draw the area, which is going to be the triangle one. Which means they said that you're gonna cross section that you have, you're gonna cut parallel to the y-axis. This means like every time you're gonna cut this makes sense. You cut parallel to the y-axis. So you can draw one line here. This is your cut. You cut perpendicular to the y-axis. And then every time you cut, you get the triangle. Every time you cut, you get the triangle. So let's try to find the area. A, X. So what is the AX here? So the area of the triangle, this is going to be the area of the triangle, right? Because if you have the area of the triangle AX, once you have the area for the first one, you're gonna integrate from A to B, whoop, everything, and then this is going to be the answer for the volume. So let's find the area of the triangle first. All right. We already get that part. All right. So the area of the triangle is going to be, okay, we have the formula here. Useful formula. The area of an equilateral triangle can be found using the formula. This one, when S is the length of one side of the triangle. So equilateral triangle means you're gonna have triangle with the same length on each side. This is called equilateral triangle. The formula for the area gonna be this one. All right, which is square root 3 over 4 times side square. And then what is the side here? So of course it's gonna be this one, right? This one, which means you're gonna need to know the length of this one. The top curve minus the bottom curve. The top curve is, okay, let's see. The top curve minus the bottom curve and then square. So what is the top curve here? It's 1, okay. For circle, it's a little bit hard for some of you because some of you don't know it. So x squared plus y squared equal to 1. You need to simplify until you get something instead of x, right? This is y squared equal to 1 minus x squared. this is y equal to plus or minus square root 1 minus x squared, right? You simplify, and then you have this one. Remember that the top part, this part, this is where y is positive. The bottom part, this is where y is negative. So basically the top part here, this is y equal to square root 1 minus x squared. The bottom part here, this is where y equal to minus 1 minus x squared here. Does it make sense? When you write out the equation of the circle, it's x squared plus y squared equal to 1. Correct? I mean, good. But when you write only the upper part, it is 1. When you only talk about the lower part, it is this one. So that means when you put it here, the top curve gonna be square root 1 minus x squared. This is the top curve. The bottom curve gonna be minus 1 minus x squared. All right, a little bit crazy, but this is actually what you have to be sharp on this chapter is like the picture. One more time, if you understand the picture, you're gonna have no problem here. This is the top one, this is the bottom one. All right, and then keep going. So you're gonna have root 3 over 4, and then here you have 2 times square root 1 minus x squared, and then square, right? Because same term, you can group it up, and then you clear everything, so you square everything, so you're gonna have root 3 times 1 minus x squared. Just this one, right? Because root 3 gonna stay, 4 gonna cancel with this 2, and then that square root sign gonna cancel with this 2, so you have that. So ax is just this one. That means now the final step is v, the volume of this one gonna be integrate root 3 1 minus x squared dx, because this is integrate ax dx from where to where. This is the part that you're gonna integrate. The cut line gonna be from negative 1 to 1. All right, negative 1 to 1, and then this is root 3, and this is 1 minus x cubed over 3, and then you plug in at x equal to 1 and plug in at x equal to negative 1. A little bit crazy, I know, but once you plug in every single thing, you're gonna have the answer for square root 3 over 3. All right. All right, this question high chance to be on the final, because it's considered as the not the easy question, the medium to hard question. So make sure that you understand and study the circle, because when you do it, you have to be expert on the circle here in order to get the volume here. All right, so I will let you sit down and cool down for 1 minute. Once we finish this one, we're not going to do more example here. Next time we're gonna do more example here, but today we're gonna wrap up the class. Another 15 minutes, we're gonna look at the proportion for the final. Okay, I think I record it anyway, so I can keep going, right? So the next one, let's trying to do the proportion for the final just before you go today. So the final exam, we already have the date for the final exam. So the date, it's going to be November 29, which is Wednesday, from 1 to 4 p.m. I'm pretty sure that the day before you have physics. So you probably need to spend time to read physics as well. So calculus, I mean, some of you only like pass, you have a good chance to get an A. So just make sure that you do out of 66, whatever you have here, in the on my course wheel, you can do 80 minus that question mark, and all you need is that what you have left. So you don't have to be worried that much about calculus compared to physics. I mean, for those of you who already did pretty good in exam 1, 2, and 3. But for those of you who want to fight for the good grade on the final, so make sure that you do the best you can. You're gonna have 11 questions this time. It's 3 hours, so it's gonna be a little bit exhausted because you have 11 questions. So question 1 to question 11. So question 1, I'm gonna ask you for the basic local max and min, and also absolute max and min. Gonna be question 1. So make sure that you actually study on how to find local max and absolute max and min. So this is actually how many points I cannot remember, but I think 7 or 8. 7, yes, 7 points. This is a good one to remember that when you do the local max and local min here. So you do the first derivative and then you find the critical number. Once you find the critical number, so you set it equal to 0, so you find the critical number. And once you have the critical number, you those are candidates for absolute max and min as well. And then once you have the question gonna ask you to find absolute max and min on the interval A, B here. So if you want to do the absolute max and min, you include your critical numbers and also the endpoints, and then you compare them. You're gonna get absolute max and min. This is similar to the one that we learned after the integration technique. The first day after we learned the integration technique. So you go back to that example to absolute max and min. It's gonna be a good guideline for you. So question 2 gonna be graph a function. This is the big one. As I told you that we already learned 4 examples in class, and we have 4 exercise that I put it for you. So 1 out of those 8 functions gonna be on the exam. This one is 15 points. A lot. All right, question 3. Question 3 gonna be the optimization one. The optimization one, the one that I put together as a word problem. The one that you learn in class, something like you trying to minimize or maximize the volume of the box, or some question that we learn in class that how to do the fence one to minimize the area or something like that. A lot of question can be on this one, the optimization. This is the optimization for 6 points. So you set up the objective function first, and then you set it to be fx, and then you dip equal to 0. That's it. And then you solve for the critical point, and that's gonna be the answer for the optimization. The hard one is you have to set up the objective function. All right. Question 4 gonna be the optimization as well, but it's gonna come with the related rates in one question together. Like this is going to be a little bit complicated questions that you have optimization and related together in one question. This is 8 points. Or 7 points, I cannot remember, but I'll get back and fix it. And question 5 gonna be related rates. This is 7 points. All right, so actually optimization, you have one question. Related rate, you have one question, but question 4 is the mix between optimization and related rate. You have to use both of them in one question. But I mean, these 3 questions are word problems. So you're gonna need to read the question carefully and trying to set up the problem. You know, the thing that we learned in class is like the problem with the swimming pool, the one that we just did on Monday, the swimming pool one. That is the example of the word problem. Also the one that you see before that, I trying to roll the cylinder and get the maximum something like that, the maximum area or something. Lot of word problem that can be on this question. So optimization and related rates here, but related rates here, the thing gonna be different because you're gonna differentiate with respect to time, and then you're trying to solve for something after you differentiate with respect to time. This one, sometimes you have to use similar triangle. Someone you have to use the Pythagorean theorem. Someone you have to use, sometimes you have to use a trigonometric function. For example, like this is all word problem. All right, for question 6, I think this is a part for application of derivative. So 7, 15, 22, 30, like this is 15, 30, and then 43 point about, and then done. And then the parts of the application of integration, you're gonna start buying the area. Write the area first. Write an area as an integral. So this one picture is given. Picture is given, but I just want you to write out what is the area of R equal to integrate what. I'm gonna ask you to do both dx and dy. Picture is given, intersection is also given, so you don't have to solve for anything. So that means you actually have picture, have intersection, everything. You just take a look at the picture and write out the area of R as an integral. So basically you want to make sure that you know that top minus bottom, right hand minus left hand, and then you set it up. This is a short question, the short one, only 4 points, because I only give you everything already. So you're gonna just need to set up integral. So question 6, you don't have to think a lot. This is the easy one. Question 7, this is the thing that we just learned, the volume by slicing. The volume by slicing. This is actually 6 points. So the thing that we just learned here, this is similar to question 7, example 156 here. All right, this is a volume by slicing. All right, so next one, question 8, 9, 10, and 11. This is going to be the one that we're going to learn next. It's going to call the volume of the solid of revolution. So later on, what we're going to learn, we're going to start from the line, and then we're going to spin the line over the axis, for example, and then you're going to get the solid. This is called the solid of revolution, and then we're going to trying to find the volume of that one. This is actually the thing. I mean, it looks that we have so many questions here, but the questions are super short because we're gonna just ask you to set up the integrate, but you don't have to integrate. Just set up. If you read the question and it say do not evaluate integral, you don't have to integrate, okay? But I mean, I will explain more about this type of question later. When we hit the content about the this and shell methods over there. And then the last question gonna be improper integral. This is the last one that we have to learn. The improper integral is you integrate, but the top part has infinity. You're gonna learn how to deal with the infinity one here. This is called the improper integral, or the one with the denominator equal to 0. So actually now you can review yourself about this, and this. You already learned this part already. So the total point for the final gonna be 85 points. We're gonna divided by 2.5, so you get 34 points. So we're gonna divide it by 2.5, so you get 34 points as your final, and then it's gonna add up with the 66 point, so you get 100 for the class here. You need to pass 80 to get an A. So this is actually, but you can see that the derivative here, this is already 43, so it's already half for the application of differentiation. The application of integration gonna be another half. So yeah, that's what we're gonna do for the final. Okay, so on the last day before, I think the last day that we're gonna learn is November 20, and then I'm gonna let you study for 8 days before the final. The final gonna be November 29. So on November 20, we're gonna come back and fill in more details here, so you know what to study. But now you can just keep going, do this one. Okay. If you have question, let me know then. So I think that's all for today. Any questions still then? All right. Okay, then, well, because we only have half of the class today, 14 students. I mean, like, yeah, for those of you who missed, I mean, like, I'm gonna just give you a record on my course view anyway. All right. Thank you, everyone. I will see you again next week in class on Monday. So we're gonna learn more about the slicing example and then the this and shell method, which is here. All right. See you next week, everyone. Have a good Wednesday. I want to say have a good weekend, but have a good Wednesday, everyone. All right. See you later. No question ใช่ไหม
Thank you.
ครับ thank you ครับ